Here's how to teach the ISME strategy. The key thing is to make sure that students employ this strategy when they get stuck on questions. You want to remind them that all the math that's tested is algebra, geometry, and arithmetic. It's stuff that, for the most part, they've all already had. So if people seem like they're giving up on questions, then you want to make sure that they're using this strategy, because there shouldn't ever be any question that they absolutely have no idea how to start on. They may not be able to do every single question in a section for time purposes, but there shouldn't be any question where they just throw up their hands and say, well, I don't know, I've never seen this. Algebra, geometry, arithmetic, they've had all that. So, for example, here's the overarching math strategy. Now, on easier questions at the beginning of a math section, you may not need to spend too much time thinking about strategy. But whenever you start getting into harder questions or even medium questions where you're not sure exactly what to do, this strategy will guide you through ISME. So the first step is to identify. If you're not sure what a question is going for or what's happening inside a question, always start by identifying the problem type, right? Your calculator may be important for calculation, but it's probably not the most important tool on any given problem. If you can figure out what concept is being tested, then you'll have a way to start the problem. Is it Pythagorean theorem? Is it an average problem? Is it a simultaneous equations problem? Identify the problem type, then you can use the corresponding setup step to get on your way. Which brings us to step number 2, set up. Write down what you know is true. This sort of breaks down into geometry and algebra. If you're dealing with a geometry problem and there's a diagram, take any information from the problem and label it on the diagram. Take all relevant information. If there isn't a diagram, draw one out, right? If they tell you about a line that's not shown, draw that line in. If they tell you about a shape that isn't shown, draw that shape. If it's an algebra problem, if you identify that it's, let's say, an average problem or a distance rate problem or a percent change problem, then you know exactly which equation you need, the average equation or the rate equation or the percent change equation. So write down whatever you need to solve the problem, right? Then you want to make sure, what is the specific answer that the question is asking for? Make sure you don't fall for one of the SAT's tricks. Remember, we talked about it in the first lecture. The SAT will often ask you for a non-obvious value, or they might switch up the units on you, ask you for feet when they've been talking about inches. So what's an easy way to make sure that you know what they're asking for? Circle the thing they're asking for. If it's 4W as opposed to W, if it's an answer in feet as opposed to inches, whatever it is, make sure you circle it. It doesn't take you any extra time, and it will help make sure that you don't fall into a trap and make a careless error. Finally, once you've identified the concept being tested, you've set up the diagram and or formula that you need, and you've made sure you're answering the right question, then it's time to do E, execute. Plug in information from the problem, write out your steps, and solve for the answer you need. After you've got your answer, check your work and make sure that your answer makes sense. This can come in a couple different ways. One way is if you solve for a variable, plug that variable back into the original equation or expression and make sure that it works. If you're dealing with a diagram, try to make sure that the length of the line segment you found looks appropriate, right? Even if the figure is not drawn to scale, you should still be able to get a sense of whether it seems roughly like the right length. Is a point that you found in the right quadrant? That sort of thing. Look for ways to check your answer. If you follow this strategy, you'll be able to deal with questions that seem harder. Remember that the math being tested is not stuff you don't know. It's just disguised to look like stuff you don't know. So make sure that you are identifying, setting up, making sure, and executing. So let's apply that to a practice problem. Number 4. In the figure above, LM equals MN. If x equals 50, what is the value of y? Well, the first thing we want to do is identify, right? Well, here we can see that we're dealing with a shape, so this is obviously geometry. What particular shape? It's the triangle. What aspect of triangles? So students will often say, well, it looks like geometry. Okay, yeah, it is geometry, but you want to push them to be as specific as possible. What is the real concept being tested? So they'll say a triangle. Okay, what aspect of triangles? Is it testing the length of a side? Is it testing area? Is it perimeter, etc., etc.? And then they'll finally come to, okay, no, it's testing an angle measure inside a triangle and next to a triangle, which means it's going to be the rule of 180. Right? Remember that there are 180 degrees inside a triangle. There are also 180 degrees in a straight line. Okay, so we have identified the concept being tested. Now we want to set up the diagram and or equation that we need. Well, they give us a diagram. Let's take information from the problem and actually set it up in the diagram. So for instance, LM is equal to MN. We can put little tick marks to show that those sides are congruent. And I like crossing off information once I have used it. That way I know what I haven't used and what I still need to work with. X equals 50. All right, we can write 50 in for X up here. And now we can cross that off. What is the value of Y? Okay, so we've set up the diagram. We want to make sure we know what we're looking for. That is Y, easy to circle. And we may as well circle it on the diagram here. Now we know exactly what answer we're supposed to give. Finally, we need to execute, right? Okay, so we have we've set up, we've made sure we're going to execute. From here, what it's good to point out is that every single piece of information in an SAT math problem is relevant. That's true probably 99.2% of the time. There's very rarely extraneous information. So often kids are not sure what to make of the fact that LM is equal to MN. Make sure, if they don't know what to do with it, try to get them to think about why that piece of information is there. Why is it important that LM is equal to MN? What are we dealing with if we have two sides of this triangle equal? Yes, we have an isosceles triangle, which means two sides are equal. And what does that mean if two sides are equal? Good, that means two angles are equal. In fact, the two angles opposite those two sides. So for instance, that angle down here, the inside of L, and this angle down here, the inside of N, these two are equal angles. We'll mark them with, let's say, 2 tick marks, just to keep things a little bit distinct. How does that help us? Well, we go back to the fact that we're being tested on the rule of 180. We know that angle L plus angle N plus 50 has to sum up to 180 to make that triangle. So we can simplify a little bit. Subtract 50 from both sides. And we get L plus N equals 130. And from what we've labeled on the diagram, we know that L is equal to N. So we could substitute in N for L. And we get N plus N equals 130. And we can finish that off then. 2N equals 130. And one last step, of course, is to divide both sides by 2. And we see that N, if we do this on our calculator, it's always good to do that kind of calculation on your calculator as opposed to in your head. We get N equals 65. So now we can go back into the diagram and label. This is 65 down here, and we know that N and L are equal, so this is also 65 over here. How does that help us? Now, if someone gets stuck here, remind them that there's a relationship between Y and 65. Remind them that we're being tested on the concept of the rule of 180. Well, the other part of the rule of 180 is that every straight line has 180 degrees in it, right? And we can see down here that we have a straight line joining Y and 65. So we can set up another equation. Y plus 65 has to add up to 180 as well. And with just a little bit of algebra, we can solve for Y. Subtract 65 from both sides. Again, go to your calculator to get your result. And you should get Y equals 115. So our answer is B. So to review, identify the concept being tested, in this case rule of 180, set up the diagram, make sure you know what piece of information you're being asked to give, and finally execute. Write out your work. Make sure that you do calculation on your calculator, but if you're doing algebra, write out your steps. That way, if you do make a mistake and come up with an answer that isn't there, you'll find it a lot easier to correct that mistake if you have your work written out. And that is how to teach the ISME strategy. Now let's look at a couple practice problems to employ it. Starting with page 37. Keep in mind that as you go through the problem types in the bulk of the math curriculum, you want to be using this ISME setup, right? Mainly because you want to hammer home the strategy to students. A lot of the problem types won't be so difficult, but a lot of them will be harder. Either way, you want to make sure you're hammering home the I, the S, the M, and the E. That way students will start to develop those good habits. So number 15, let k heart j be defined by the sum of all integers between k and j, inclusive. For example, 4 heart 8 equals 4 plus 5 plus 6 plus 7 plus 8. What is the value of 60 heart 150 minus 61 heart 149? Well, this is what we call a pattern problem, or pairing or counting problem. How can you identify these? Well, any problem that seems like it would take a ridiculously long time to solve. For example, in number 15, we're dealing with not only a pattern problem, but we're dealing with what we call a weird symbol function, right? This heart is just a weird symbol. It has no meaning in normal math, but the problem assigns it meaning, right? So the first thing is to kind of parse that. The heart, according to the described function, means that we add up all the integers between the two inputs, inclusive, right? So for example, 60 heart 150 means we're adding up all the integers from 60 to 150, including 60 and 150. Well, you can tell that's a lot of numbers. If you went to your calculator and started punching in 60 plus 61 plus 62 plus 63 plus 64, that's going to take a really long time. Not to mention, what if you accidentally forget a number, or you hit 662 instead of 62? Really a high possibility, or relatively high possibility, of human error by doing that. So this is a pattern problem. It would take a really long time to add up all these numbers and then further to subtract all these numbers, 61 to 149. So instead we want to look at the setup. What is the setup for these pattern problems? Well, start by working out the first three terms, and if possible, the last three terms. So let's just start with 60 heart 150. We know, according to the function described, that the first three terms are going to be 60 and 61 and 62, and of course we're adding between those terms. Now, it's also a good idea to write ... to encapsulate the middle of the set. We're not going to write out every single number, but we do want to represent the fact that there is stuff that we're not writing out. After the ... the ellipsis, we want to write out the last three terms. Well, in this case, the last term is going to be 150, so before that will be 149, right before that will be 148. All right, and we can just go ahead and get rid of this gridding box for the moment, just to give ourselves a little more space. Okay, now we want to look for patterns, but in the make sure step, first off, we want to make sure we're not intimidated. This looks like a hard problem. There's a weird symbol and there's a lot of numbers involved. It's a pattern situation. But it is going to be math that we know how to do as long as we follow the steps here. Common patterns to look for include repeating numbers. Well, we don't see repeating numbers just in this top set. Numbers that can be paired if we're adding. Okay, well, we are adding here, but we also want to pay attention to numbers that can cancel if we are subtracting. Now, we are adding just in this top line, but there is subtraction here. So before we start worrying about the top set, let's just write out the shorthand for the second set, 61 heart 149. Well, again, the first three terms, 61 plus 62 plus 63, ... to show everything in the middle that we're not going to write out. And then the last three terms are going to be 147 plus 148 plus 149. So now we've written out the shorthand for that second set. And here's where we really want to start looking for patterns. Yes, we are adding within each set, but the more dominant operation is this subtraction, right? We're taking the top set and subtracting the whole bottom set, which means we want to put parentheses around that whole bottom set to make sure that negative sign gets distributed throughout. And if we are subtracting, we want to look for numbers that will cancel. So at this point, I would ask my students, do you see a pair of numbers that will cancel from top to bottom? Notice that we have all these positive numbers on top, and we're subtracting all of these positive numbers on bottom. And usually a student will say, oh yeah, it looks like the 61s will cancel out. Well, we have 61 on top, and we're subtracting 61 on the bottom, right? Remember that negative sign here is going to distribute throughout. And then someone else will say, oh, okay, well, 149. Yep, we have 149 on top, and this negative sign, again, will distribute through. That means we're subtracting 149. So 149 minus 149, those cancel to give us 0. Someone else will say, well, okay, 62 and 62, good. Someone else will say 148 and 148, good. Again, the negative sign is distributing. And then, if anybody gets stuck, point out that while we haven't written out all the numbers in the top, we know, for example, that 63 is part of the set on top. We just haven't written it because we're not going to write out all the numbers. But that means we can cross out the 63s, right? And likewise, we can cross off 147. We haven't written it on top, but we know it's there, right? Basically, these two sets have the same exact middle, which means we can cross off everything in the ellipses, right? At this point, here we are executing. Once everything has been paired or canceled, see what's left over. Well, what's left over in this question? The only two numbers that don't cancel out, 60 and 150. And what operation do we have between them? We have addition, right? So 60 plus 150 gives us 210. And there's nothing to subtract on the bottom. It already all got canceled out. So this is a good example of a difficult problem. Most students look at this, get intimidated, and say, I have no idea what to do. If you can convince them to use the strategy, in principle here, that means setting up the terms, right, using the shorthand so that they get a sense of what the set looks like. If they don't do that, it's going to be hard to look for the patterns, right? We want them keeping their pencils moving, crossing things out, canceling in this case. So that means they got to write out the sets. Let's take a look at another practice problem where we can use ISME. So here is an average problem. Well, how do you identify average problems? Look for the words average and arithmetic mean. They'll always put arithmetic mean in parentheses to clarify that they mean what we think they mean by average. So number 12, the average arithmetic mean score of 6 teams is 80 points. If the average score of 4 of the teams is 75 points, then what is the average number of points scored by the other 2 teams? First things first, we want to identify. We see the word average and this phrase arithmetic mean. We know we're dealing with average. Concept identified. Now we go to the setup step. List the elements you know and plug them into the average formula, which is this. Average equals the sum of things divided by the number of things. All right, well, in number 12, we know we've identified an average problem, which means we're going to need the formula average equals sum divided by number. Make sure you include all the elements. Okay, well, in number 12, we see a lot of, or several pieces of information. One good thing to point out to students here is that when you're doing a formula-based problem, like an average problem or a rate problem or even a percent change problem, you don't necessarily need to read all the way through before you start plugging things in. In fact, if you do read all the way through, that might make things confusing because you're going to see a couple different numbers and try to plug them into the same equation, perhaps, and that's not going to work. So, for example, all right, let's look at number 12. We want to look for elements that we can plug into this formula. We want to look for averages or sums or numbers, right? So let's just start reading it again and see what we can plug in. The average score of 6 teams is 80 points. Okay, well, we can stop there and see what elements we can plug in. It tells us that the average score is 80 points, right? So we can plug in 80 for average. And it tells us we're dealing with 6 teams. Is 6 teams the sum of the points, or is that the number of teams? Well, obviously it's the number of teams, so we can plug in 6 there. Now, do we know the sum of the points? No, the problem doesn't tell us how many points those 6 teams scored in total. But once we've plugged in 2 elements in the equation, we can solve for the third. How do we do that? Multiply both sides of this equation by 6, and then we can solve for sum, right? Well, 6 times 80 is going to give us 480. And the 6's will cancel out on the right side, and we're left with 480 equals the sum. And I'll put a little sub 6 here just to indicate that this is the sum of the 6 teams. Now, you want to have your students keep telling you as they read what to plug in where, right? Make sure you're not doing all the work. Let them tell you what goes where. So, let's take a look at the next piece of information. If the average score of 4 of the teams is 75 points, well, again, we can stop right there. So-and-so, can you tell me which of these pieces of information I can plug in where? Okay. So it says the average score is 75. So where do we plug that in? Good. We plug it in for A, right? 75 is the average, and that's got to be equal to the sum divided by the number. What other piece of information do we have, so-and-so? Great. We have 4 teams. Is that the sum or is that the number? Good. Just like the previous instance, this is the number, right? The number of teams. Do we know the sum? No. So we can just leave it as sum, right? And just like we did above, now we can solve for the missing quantity sum. Just multiply both sides of the equation by 4. Simplify, and we get 300 equals the sum of 4 of the teams. Okay? Let's look at the final piece of information, or the question itself. We want to know, what is the average of points scored by the other 2 teams? Well, so-and-so, what else can I plug into the average equation? Okay, good. This time we don't know the average. We're asked what is the average, so we've got to leave A as average. Do we know the sum or the number? What other piece of information do we have? Okay, good. We're talking about 2 teams. Is that the sum or the number? Good, that's the number. In this case, the number of teams, 2 teams. Now, notice that we are not provided the sum of their points. If someone gets stuck here, you want to remind them that every piece of information is critical to solving the problem. The steps they've already taken are going to help them get to the answer. So if somebody were stuck, I would ask, well, how did the steps before help us? Why did we have to figure out the sum of all 6 teams and the sum of all 4 teams? Right, because if all 6 teams scored a total of 480 points, and 4 of those teams scored a total of 300 points, the other 2 teams must have scored the remaining points. So, all we need to do is subtract. 480 minus 300 gives us 180. That represents the sum of the other 2 teams' scores. And now we can plug that in for sum. And at this point, it's basically arithmetic. Algebra, or average, equals 180 divided by 2, which equals 90. And D is our answer. Notice that the concept itself is pretty straightforward. You guys have all used average hundreds of times, right? But the problem is complicated because you have to use the average formula 3 times in succession, and you have to make sure you plug the right stuff in to the right equation, right? If you read everything and try to plug everything into one version of the equation, stuff is going to come out wrong. But the main thing is not to give up. Keep your pencil moving and do things step by step. So that's how to teach math. Essentially, you want to make sure that students are following the ISME strategy and remind them as often as you can that this is math they know how to do. It's just about breaking it down into easier pieces. Sometimes that means recognizing a concept that seems not apparent when they first read the question. Sometimes it means a concept that may be apparent but has many iterations, as in this case with the average problem. Make sure they do things step by step so they don't get intimidated.